A car of mass 1200 kilograms tows a caravan of mass 1800 kilograms along a level road. They are linked by a rigid tow bar. The car accelerates at 1.80 meters per second squared, propelled by a motive force of 5600 newtons. Assume the resistive force on the car due to friction and air resistance to be a constant value of 65.0 newtons. Calculate A. The resistive force F on the caravan,
and B. the tension in the tow bar.
First, I note down all the values that are given in the question. Mass of the car is 1200 kilograms, the mass of the caravan is 1800 kilograms, the acceleration is 1.80 meters per second squared, the force exerted by the motor is 5600 newtons, and the frictional force acting on the car is 65.0 newtons. Now note that the acceleration of the whole system of 1.8 meters per second squared has to be equal to that of the car and that of the caravan. Second then, I note that the vertical forces are in equilibrium, so we can focus on the horizontal forces. Third, we take now the caravan and the car as one system and we draw all horizontal forces acting on the system, which is here not to scale because the frictional force on the car is much smaller than the force exerted by the motor. We note that the tension in the tow bar is an internal force which is not acting on this system as a whole, so it can be ignored in this step. And we only have the force exerted by the motor, the frictional force acting on the car, and the frictional force acting on the caravan. As the mass in this system is conserved at 3000 kilograms, we may use Newton's second law to be that the net force is equal to m times a, which in this case is equal to 3000 times 1.80 is 5400 newtons. We also have that the net force is given by the force exerted by the motor minus the frictional force acting on the car minus the frictional force acting on the caravan. Plugging in the given values and rearranging, we find that the frictional force acting on the caravan is equal to 135 newtons.
Now for part B of the question,
we take the caravan as an independent system and we draw the forces acting on the caravan, which, if we only look at the horizontal forces, are the tension in the tow bar and the frictional force exerted on the caravan. Again, the mass in the system is conserved at 1800 kilograms, so we can use Newton's second law to be that the net force is equal to the mass times the acceleration, which in this case is 1800 times 1.80 is 3240 newtons. We further have that the net force is given by the tension in the tow bar minus the frictional force exerted on the caravan. Plugging in the values that we found before and rearranging, we find that the tension in the tow bar is equal to 3375 newtons.